So here is question number 16, everyone. The equivalent resistance between point A and B would be what? Now, we need to modify the circuit first of all. So let us name the junctions. Suppose this is junction 1, this is junction 2, this is junction 3, here is junction 4, it is junction 5, and this is junction 6. The process starts from A. A and junction 1 both are together. So here is junction 1. See, 2 and 5 are connected with a direct wire. So they are at the same potential. Similarly, 3 and 4, they are connected with direct wire. So they will be also at the same potential. So let us write 2, 5 here. They are at same potential. So we can give them a common point. Here is 3 and 4, same potential, that's why a common point. Now suppose here is our B, which is in association with 6. Now between 1 and 2 there is 2 ohm resistor. So this is 1, this is 2. A 2 ohm resistor will be here. Between 1 and 3 there is another 2 ohm resistor. So let us take 1 and 3 and add another 2 ohm resistor. So we have covered this and this. Now between 2 and 4 we have 10 ohm. Here is 2, here is 4, 10 ohm. Between 2 and 3, 5 ohm. So 2 here, 3 here, 5 ohm. Between 5 and 3, 20 ohm. So 5 here, 3 here, 20 ohm. And between 4 and 5 there is 15 ohm. So 4 is here, 5 is here, another 15 ohm we have to take. So this is all covered. Now between 6 and 4 we have 2 ohm. So 6, 4, 2 ohm. Between 6 and 5 we have another 2 ohm. So here is 6 and here is 5. Another 2 ohm. So this is the modified circuit, everyone. Students, this complex circuit can be modified into this circuit. Now if you see closely, what you will find, this resistance upon this resistance equals this upon this. The condition is satisfying the Wheatstone-Bridge condition, and in those cases no current will go across this, so therefore they can be removed. Since R1 upon R2 equals R3 upon R4, therefore this can be removed and circuit is simplified as this way. A 1 2 ohm and another 2 ohm in series, 1 2 ohm, another 2 ohm in series. This is B and here is A, 2 2 2 2. After solving we will get the value of equivalent resistance, that is 2 2 in series 4, 2 2 in series 4. 4 and 4 are in parallel. The result will be what? 2 ohm. So the net resistance between A and B will be 2 ohm, and we can go with option number 2 only. Now move on to the next, that is 17 number. So here is question number 17, everyone. A spherical ball of radius capital R is floating in a liquid with half of its volume submerged in the liquid. Now the ball is displaced vertically by a small distance and released. The time period of oscillation of the ball will be what? Now at equilibrium condition, what will happen? The ball is floating on the surface of liquid. It means what? The weight is balanced by the buoyant force. So weight will be what? Volume of object, density of ball, gravity will be balanced by upthrust force, that is half immersed V by 2, density of liquid multiplied by gravity G. From here it is clear that density of liquid is equal to 2 times density of ball. Equation number 1. Now we have displaced by a distance x to the ball. It means the extra force exerted by the liquid will be given by F equals by unforced, that is minus is showing the restoring force, dV, extra volume of object submerged, multiplied by gravity g, density of liquid. So we know very well net force equals mass into acceleration. So mass of ball into its acceleration minus dV will be what? Area into the extra distance. Area will be pi r square multiplied by x g rho L. Mass can be given as 4 by 3 pi radius capital R cube into volume into density. So density is rho p a, that is minus pi r square x g rho L. R square will be cancelled with this R cube, pi will be cancelled with this pi, and solving it, what we are going to get? 4 r rho b into a equals minus 3x g. Rho L equals 2 times rho b. Putting it here, 2 rho b. Rho into b, rho b and rho b cancel out. 2 2 ja 4. Now we are getting the value of acceleration a as minus of 3g divided by 2r into x. Now this equation is analogous to a equals minus omega square x. Therefore SHM would be there, and we can write omega as under root 3g upon 2r. Once omega calculated, now we can calculate time period as well. T equals 2 pi by omega, that is 2 pi under root 2r upon 3g. So this is our final answer. Now let us check the options. Option number 3 is perfectly matching. So we can go through option number 3, which is absolutely correct. Now move on to the next, that is 18 number. So student, here is question number 18. A charge minus q is placed inside a hollow conducting sphere of radius r as shown in figure. The electric flux through a closed imaginary spherical surface of radius 3r will be what? Now this is the sphere which is charged by minus q, and we have to calculate the phi flux enclosed with this 3r hypothetical sphere. We know very well here in this case the same flux passing through radius 3r also. Since the same flux will pass through radius 3r. Therefore, according to Gauss theorem, we have net flux bounded will be what? Q enclosed divided by epsilon naught, that is minus q upon epsilon naught. Let's find out the options. We can say that option number 3 is perfectly matching with our answer. So option number 3 we can go with. Now move on to the next, that is 19 number. So here is question number 19, everyone. A negative charge particle of charge q and mass m is projected between the plates of parallel plate capacitor as shown in figure at time t equal to 0. The time of flight of the particle will be what? Neglecting the effect of gravity. Now see, this is the particle. Electric field direction is from plus to minus, that is this is the electric field having value sigma upon epsilon naught. Now negative charge will experience a force opposite to electric field. So the force acting will be in this direction, and hence acceleration will also be in this direction. The particle is projected in this direction, acceleration is downward. So this is an example of projectile motion which we have covered in class 11th. The trajectory of particle will be parabolic. Now We know very well the time of flight for the projectile is given by 2u sine theta divided by g, where acceleration is here, that is a. So let us calculate the acceleration first. Force is equal to mass into acceleration, and that is QE here. So acceleration will be Q into electric field sigma upon epsilon naught mass. So this is acceleration. Then time of flight can be written as 2u sine theta upon acceleration, that is Q sigma epsilon naught m. Rearranging it, we get T equals 2mu epsilon naught sine theta upon Q sigma. So this is our final answer. Now checking the options, we can say that option number 2 is perfectly matching. So we will go with option number 2 only. Now move on to the next, that is 20 number. Now here we have question number 20, everyone. A semicircular conducting rod of radius r moving in a region of uniform magnetic field B as shown in figure. The potential difference between C and D, that is VD minus VC, will be what? Now in this question we have to calculate the induced EMF between these 2 points D and C. So we know very well the induced EMF V induced can be written as B V and L effective distance. L effective will be what here? See, this is the rod from C to D, but we can take this as L effective. This is our L effective. Now how we can calculate this? See, this is radius r. This is angle 30 degree. It means this angle is 60 degree. So if this is r, then this length will be what? R cos 60 degree. This is already radius r. So effective length or L effective, we can write r cos 60, that is r by 2 plus r. Solving it gets you 3r by 2. Now the condition is something like this. This is a rod of L effective length moving with velocity v in this direction, having magnetic field perpendicularly outward. Now we can calculate it. Induced EMF V induced is equal to magnetic field, that is B, speed v, length 3r by 2. Solving it gets you BVR into 3 by 2. Option number 3 is perfectly matching, so we will go with option number 3 only, which is the correct answer. Now move on to the next, that is 21 number.